So that's what happens here. Okay, and again, just reminding you what the R and N are. You know, R is that annual interest rate, but you're writing it in decimal form, so it's not a percent. And little n, right? That's how many compounding periods there are in a year. So again, n is how many compounding periods there are in 1 year. Okay, now, hopefully you can see from here, excuse me, but basically as n goes up, right, your compounding frequency, as the compounding frequency goes up, right, the percent increase goes up. So if it's compounded more and more, your percent increase in the balance goes up. In other words, your APY goes up as n increases. Now, so as an example, let's say we want to calculate the APY, okay? And let's say the account pays 4% and it's compounded monthly. So in other words, our R, excuse me, so the APR here is 4%. So you have to convert that to a decimal to get R. We know that N is 12, right? Compounded monthly. So we calculate it just using this formula. Notice that, notice that the initial balance, the starting principal, the principal that is not here. That doesn't make a difference. So even though we don't know how much we deposited into this account, that doesn't make a difference. And it's just direct calculation. I know here I did 4 decimal places. I said round to 2. At the very end, though, when we convert to a decimal, to a percent, we have 2 decimal places. So we have that. So it's a little more than 4%. Okay, that's one example. Let's do another one. But actually, let me ask this. Do you have it? What questions do you have? Yeah?
So basically, you're just plugging everything in that you give us in like the word problem.
Yeah, into the right part of the formula.
Okay.
That's all. Right? So here, for instance, since it's compounded monthly, that tells us our N is 12, 12 months in a year, right? And since the account is paying 4%, which is the APR, okay, that tells us R is 0.04.
Okay, that makes sense. Thank you.
You're welcome. Good. Good question. Any other questions? Here's another. Okay, so here's another one. Same formula, right? This is our formula. So let's now get the APY for an account. It's paying 12% and it's compounded daily. Okay, so compounded daily, right? To use the formula, there are 2 things we really need, right? We need R and N. Well, can we get those? Well, the percent, right? The account is paying 12%. Our R, see if we can draw this, is 0.12. That percent, but you're writing it as a decimal. Compounded daily, well, that tells us what N is. That's how often it's compounded in 1 year. So daily, what does that tell us? 365. So N is 365. So we plug that into the formula. And when you do that, what happens? We get this calculation. And that's equal to 0.1275, which is approximately 12.75%. Now, so that's what happens here. I already said that you really don't need the initial amount, right? How much was deposited in the beginning. But let's just suppose that we deposited $1,000. Let's suppose we did that. Okay, so with these two values here, R is 0.12 and is 365, right? Let's determine how much will be in the account after 1 year. So this is our P0, right? So going back to our formula, P0 is 1,000. After 1 year, so T is 1. So we have this amount after a year, which well, we have $1,000, right? This is how much we have after a year. So by what percent is this bigger than this? Well, we calculate, we get the percent change, right? This is the ending amount minus the starting amount over the starting amount, which is this. And if you were to, that's the relative change in our balance after a year. And if we converted, okay, to a percent, we would get this. All I'm trying to show you is, even if we had the balance as $1,000, because here I never said what the balance was, we will get approximately this as our percent increase. I mean, we only get a close approximation, but that's really due to round off error. Okay. All right. So again, this is just another example with annual percentage yield. That's all this is, APY. I want everyone to try some now on their own. Are there any questions though? Yeah?
How come the first one has like the -1 and then when you did it after 1 year it doesn't? Like what does that represent?
The -1?
Yeah, because it's the same formula after 1 year, you just don't have -1.
Well, that came from when we derived it because we want to get the percent increase. And so by our formula, we have to get the relative change, right? And then convert that to a percent. That's what percent change is. So this is the balance after 1 year, right? And since we're compounding, this is the formula. Basically, there's a T normally. Here, let me go to it. The T here I take to be 1 because it's 1 year. Okay. Then I'm subtracting the starting amount.
Oh, okay.
Then,
I see. I see now.
Okay, good.
Yeah.
Awesome. Okay, very good question.
Thank you.
You're welcome. Any other questions? I mean, it just boils down to using this formula. You have to figure out what R and N are, and that's what happens. And then you get it. So for the next one here, I want everyone to try these on their own for a bit. We'll take like 4 or 5 minutes, okay? The formula is here. Actually, you know what? I'm going to put the formula on the next slide here. Let me just do that. Up there it is. So here, this is the formula you're going to use. Okay. So I want everyone to work on these for like about, take like 4 minutes, like 4 or 5 minutes. So I'm going to stop the recording.